So start out by determining, is x plus 1 a factor of the polynomial? So remember, figure out if it's a factor, we have to divide. I usually use synthetic division. With x plus 1, we do the opposite in the corner. Then I take my coefficients. X to the third is 2. X squared is negative 3. X is 1. 8 is our constant. Leave a spot. Drop down 2. Multiply. Add. Multiply. Add. Multiply. Add. Because our last number is 2, the remainder is 2. If there is a remainder, it is not a factor. Was x plus 1 a factor? No. What's the remainder? The remainder equals 2. So I can't state the 0. All right, so here we're going to make a new connection. And this was why we did the worksheet from last week. What is f of negative 1? So I'm going to replace each x in the equation with negative 1. Remember, we do exponents first. Negative 1 to the third is negative 1. Negative 1 squared is positive 1. Multiply. Multiply. So we get negative 2, negative 5, negative 6 plus 8 is positive 2. So f of negative 1 is positive 2. What do you notice? Pay attention to that. Determine if x minus 3 is a factor. How do we determine if something is a factor? We need to find the remainder. So I'm going to use the opposite of 3. Take my coefficients, 1, negative 4, 1, 6. Draw the line. Drop the 1 down below. Multiply, add, multiply, add, multiply, add. The remainder is 0. Therefore, I'm going to write it this way. Therefore, x minus 3 is a factor because the remainder is 0. So this is yes. The remainder is 0. So if x minus 3 is a factor, that means x equals 3 is a 0. Because that's going to be one of our x-intercepts because it's a factor. Now let's find f of 3. 3 to the third minus 4 times 3 squared plus 3 plus 6. Raise our power. 3 squared is 9 times 4 is negative 36. 27 minus 36, negative 9, plus 3 is negative 6, plus 6 is 0. F of 3 equals 0. So when I plug in my 0, when I plug 3 in, it makes the whole equation equal 0. The remainder always equals the value you plug in. So the factor theorem states, if a value makes the equation equal 0, the binomial x minus a is a factor of the polynomial. You might want to write that in your notes. This is the factor theorem. So if I want to determine is x minus 2 a factor, you have to find the remainder. So you have two choices. You can do the synthetic if you want to do that part of it. But you also can just plug the opposite of the number in to the whole equation. When you plug the number into the equation, it gives you the same value as you get when you divide. So you have a choice of either plugging it in or doing the synthetic. Since a of 2 equals 5, the remainder equals 5, therefore it is not a factor of letter A. So go ahead and work your way through and determine and then talk to a partner to see if they agree or disagree. All right, last problem. Determine if x plus 1 is a factor, but notice this time it says write the depressed polynomial afterwards. Since we have to do that, I'm going to use synthetic division. I've kind of noticed also synthetic division, the numbers are a little smaller than when you plug the numbers in. But you can do either way to figure out, is it a factor? So then I'm going to write down my coefficients. Draw my line. Drop down 2. Multiply. Add. Multiply. All right, what did I do here? Oh, for God's sakes. I'm multiplying times the wrong thing. Multiply, add, multiply, add. All right, so this gave me a 0. Now watch what I'm going to do. I'm going to bring down this. I'm going to put my x's back into the problem. Then I'm going to put my x's back in here. I'm going to bring my constant down first. And then here's my depressed polynomial right here. All right, so that's it.